let's look at the last objective, which is using a Venn diagram to model a chance process and calculate probabilities involving two events. So here's a couple of pictures just to help you understand how a Venn diagram can be used. This first one is just a reminder of the complement rule. Anything outside of this circle is not A, and not A is symbolized with the superscript C. So this green area is not A. Two events that are mutually exclusive have no overlap. They can't occur at the same time. So this is a Venn diagram of two mutually exclusive events, A and B. There's no overlap. Events that are not mutually exclusive are shown in these bottom ones here. And we're going to learn a new term called an intersection. The intersection of A and B is the same thing as the probability of A and B occurring at the same time. That is that intersection of the two circles. The union is an or statement, and that is going to be anywhere. If it's an or statement, that means it's just A, it's both A and B, or it's just B. So you need to remember that U is union and N is intersection, and the symbol for it is up here, A intersection B, A union B. The best way to remember is intersection like this. And then you have union like this. So the U is a union and the N is an intersection. So let's use the previous example that we had to create a Venn diagram from our two-way table. So we had pierced ears and males and females. So this intersection where they were both male and had pierced ears is going to go in the middle, in the overlap, because B was having a pierced ear and A was being male. So there were 71 males that were did not have pierced ears, and you can see that here. And there were 84 that had pierced ears but were not male. So that would be the 84 were females and had pierced ears. So I want you to get used to the symbols or probability notation for each of these. A and B is males and pierced ears. That's the 19 right here. A and not B is male and no pierced ears. That's the 71 we just talked about. Not A and B would be they're female and they have pierced ears. That's your 84. Not A and not B. So they are female and no pierced ears, which would be this 4 outside. So it's outside of both circles A and B. You need to remember that for a Venn diagram, event B is everything. The probability of B occurring is everything in the circle. So it's 84 plus 19. The probability of A occurring would be everything in the circle, 71 plus 19. Let's take a look at an example together. A survey of all residents in a large apartment complex reveals that 68% use Facebook, 28% use Instagram, and 25% use both. Suppose we select a resident at random, make a Venn diagram to describe the sample space for this chance process using the events. F, picking someone who uses Facebook. I, someone who uses Instagram. The first thing you need to make sure you do when you're making a Venn diagram is you draw the rectangle to represent everyone that's outside of the circles. So I've got my two events, F and I, Facebook and Instagram. Whenever you are making a Venn diagram, you always need to start with the intersection. So how many or what percent use both? 25%. Then I have Facebook. How many people or what proportion of people use Facebook? They tell us that it is 68% use Facebook. So I need to do 68 minus the 25 because I'm already including 25%. So 68 minus the 25 is going to give me 43% use only Facebook here. Now my entire circle adds up to 68%. I need to do the same thing for Instagram. There are 28% who use Instagram, which means 25 already in there. I only have 3% left over here. And now I need to see what this totals up to find out how much is left, because all of my percentages should add up to 100%. So I will take 100% and subtract these values to see that there are 29% who use neither Instagram nor Facebook. And so this is my sample space from a Venn diagram. And they want us to find the probability that the person uses neither Facebook nor Instagram. So I've said that I want you to use probability notation here because I want you to get used to the notation. So this written out would be neither Facebook nor Instagram. The probability of not F and not I. And like we showed, that's going to be whoever is on the outside. Find the probability that the person uses Instagram. So the probability of I in this case, and they told us this in the problem, which is 28%. But this is just a reminder, the 28% is the entire circle of Instagram. Find the probability that the person uses Facebook and not Instagram. So they're in the Facebook circle, but they are not in Instagram circle. So that is this 43 use Facebook and not Instagram. And then finally, find the probability that the person uses at least one of the social media platforms. At least one would be the probability of them using just Facebook, both, or just Instagram. So the probability of Facebook or union Instagram. So just looking here, I can see that it's going to be only those included in the circles, because this is the people who use neither. We want at least one. So that would be 3% plus 25 plus 43%, which would be our 71%. Now there is another way to solve this problem as well. You can solve this problem using the general addition rule, because this is an or statement here. So we could do the probability of, so this is just the general addition rule written out, add them and subtract the overlap. So the probability of them using Facebook was 0.68, it was the entire circle. The probability of them using Instagram was the entire circle, 0.28. The probability of them using both was the intersection or the overlap, which was 25%. And this will add up to 0.71% as well. So there are two ways to solve this one. I recommend the first method. I think it's the easiest to see. I see students get confused when they try and use this second formula, but I want you to be aware the general addition rule will always work if you're working with an or statement. So take a minute and see how you do on these extra practice problems.